Now let us look how you prove trig identities. What are the critical things that you need to watch out for? So here you have to prove that your left hand side is equal to your right hand side. Okay, so now you are going to start working with your left hand side. So let us take our left hand side and say our left hand side, we know that 1 divided 1 plus sine theta plus 1 divided by 1 minus sine theta. Right, so now when you look on this expression in your denominator, if you look on your denominator, you can look at it as if it's an algebraic expression. So this can be looked at as if you've got 1 plus x and this one is 1 minus x. So now mostly when we have expressions like a fraction, it's like an algebraic a fraction. So when you've got something like that, so what you do, you go to your denominator, you look for your lowest common denominator, which is 1 plus sine theta. So always when you are working with these, it is proving trig identities, or you are simplifying the trig expressions. Think of them as if you are working with algebraic expressions. So 1 plus sine theta to this whole expression, it is going to be multiplied by 1 on your numerator. It is 1 minus sine theta, and then you're going to have your plus 1 minus sine theta to this whole expression. It will cancel out. You are going to have be left with 1 plus sine theta multiplied by 1 in the numerator. So this is going to be 1 plus sine theta. So what you do now, you simplify your numerator, you open your brackets, which is 1 minus sine theta plus 1 plus sine theta, that is on the numerator. You still move with your denominator, which is 1 plus sine theta, 1 minus sine theta. What do you see on your numerator? This is 1, this is that, so this is going to be equal to 2. And then look on your denominator. On your denominator, the expression 1, remember we said 1 plus sine theta can be looked at as 1 plus x, whereby you are treating sine theta as if it's a variable. So when we simplify this in algebraic terms, this is going to be 1 minus x squared. So we take this idea, we come and apply it in our denominator. So our denominator is going to be 1 minus sine square theta. And then you remember that you've got a trig identity. We know a trig identity which says that if you've got sine square theta plus cos square theta, this is equal to 1. This is a trig identity. So you can simply make your cos square theta a substitute formula whereby you've got 1 minus sine square theta. You are guided by what you have here. Having done that, you come in and say, I know that if I've got this, so this is going to be 2 over cos square theta. And then you say, do it now. It seems this is simplified, and when I look on my what I was supposed my right hand side, this is exactly as my right hand side. And then you conclude and say, therefore my left hand side is equal to right hand side. The way you think about proving the identities, it does not matter how complicated they may seem, how simple they may seem. What is important, always treat them as if they are algebraic expressions we have treated sine theta as if it's a variable x, and then we applied the thinking of algebra, and then we applied that algebraic thinking every step of the way, but remembering the rules of trig. That means we were aware of these rules. These are the trig identities. We remember them and then we apply them every step of the way, whereby we needed to simplify. So that's how you would apply, you would prove the trig identities. We will be looking at more complicated ones, but this one, it is just the simplest one, but you apply the same thinking irrespective of how complicated the trig identity is.